So one of the things that you have to note here is that hash tables are not based on some magical formula or some sort of a completely new construct. It's essentially building over one of the properties of another data structure that we saw earlier, which is arrays. So just a quick recap, which is whenever we talk about arrays, like let's say if our array is really large, like let's say if it has almost 1 billion elements. Okay, so if it has 1 billion elements, and if I tell you what is the element that is at 55,000 location, or what is the element at 55 million or 550 million, you can essentially traverse into this array or like go to that particular position in constant time. Why? Because we know that when we are dealing with an array, we have the starting index and we can compute where the physical value will be in the array based on start index plus size of one element into the index that we want to reach. And why this works is because we know by design that in an array, all elements are stored in contiguous memory locations, which is they are adjacent to each other rather than being laid out anywhere in the memory. So we are going to exploit that fact here today to actually design our hash table. So let's get started without further ado. We are going to talk about, like, let's say if we had a few values, like some integers, we can use an array to store them into a set, which is, or represent them as a set. And I'm not talking about this way, which is like, let's say we have 11, you just add it at index 0. If you have 2, you add it at index 1, which is the next available position, 5 at index 2, and so on. Like, this is not correct. Why? Because if we were to do this, insertions would take like on time. Why on? Because although we might have pointed to the next available position, from a property of a set that it cannot contain duplicate elements, you'll still have to start from the first element and move to or pass through all the elements to see if that element doesn't exist. Because if it doesn't exist, then only you can add, like let's say if I wanted to add 14, I would still have to compare with all of these before adding it. So this is not the mechanism that I'm talking about, which is this way we will not be able to exploit the constant access. Another reason is, like, let's say if we had used this mechanism, if we were doing the search, then we would have to go through the entire array because elements are just randomly stored into the array. So essentially, like, that would again be on. Now, to actually exploit the constant access, what we are going to do is we are going to assume, like, we are going to make an assumption. Like, initially we are just going to start with assumptions, and then we are going to abstract it further for different data types, and we are going to build upon how the hash table comes into existence. So what we are going to assume here is that we have a range of data that is available to us. So let's say if we have integers that are from like 1 to 200. So what we are going to do is we are going to use like an array of size 200, because we know from our fact that all the integers that we have is like I've taken an arbitrary number here is 200. It could be a big number like a trillion. Okay, so we are going to define a large array of size trillion in that case. And what we are going to do is, if the value that we are going to insert, if that value is there in the array, like how we are going to check it or not is we are going to map these data points to the indices in the array. So essentially you'll have like indices, and let's say if we have like the number 11 that we want to insert, we are going to check if there is an element at the index 11 in the array. If that's the case, then you skip it because we know 11 has already been inserted. If it is not there, you can just use like a Boolean array to represent all of this and change the initial values of false to true. So that's what we are essentially doing, which is in this case, when we insert an item, we set the value at an index to true. So essentially, if I wanted to insert 11, 2, and 5, you can see in this array 2, 5, and 11 are set to true, and all the other ones are false. That's the entire premise of this. So now, if we were to look up or insert, like let's say if we were to insert a value like 14, what we do is we just do ARR of 14, like I'm calling this ARR, and we are going to set this to true. So essentially this is just an O1 operation, because we can actually access the position in an array like in O1 time, which is constant access. And if we were to search a value, which is if we were to do something like search if or find if 14 exists in this representation of a set here, like we are just talking about sets here, but maps are pretty trivial, which is you can add another column here to represent like a key value pair, because we never deal with values, we always deal with the keys, and we know that keys here on the left are essentially same for like both sets and maps. So essentially what I was trying to convey was the searching operation can also be achieved, like if the value 40, if at the 14th index we see a true flag, that means it's true. Otherwise, like the element does not exist in the set itself. So essentially this is also an O1 time operation. So this is just like a small class here, which I have created. Like you can see the whole source code on what I was trying to convey, which is this is a representation of an array set using this really naive approach, but you can build upon this for more sophisticated representations of hash tables, as we are going to see throughout the lecture, which is I have this class called array set. I have a private member which stores my actual data structure, which is in this case an array of booleans. It could be an array of strings or it could be an array of integers, but the basic idea is behind the general idea is kind of the same. I have set this to false initially, and I have just two methods here. It could have like multiple methods like remove, erase, it could have an iterator to iterate over the set and so on. So essentially I have two methods here, insert and search, and whenever I'm trying to insert a value, I just do set of value equal to 1, which is 1 represents like true in C++. So I just change the flag from false to true. And for search, I just return the value of set of value. So it's like really simple. And here I create a set object, which is I've now defined this as a set called test set. Here is how I insert a value, and here is how I search a value. So when I do test set dot insert, you have like 5, which is inserted into a set. And when I do test set dot search 15, it basically returns false because that's not in the set, and test set dot search 5 returns true. So this is just one way to like use a hash table, like implement a hash table, but this is a very naive way. We are going to see what are the problems with this in the next video.